So you might find yourself in a situation where the data that you're trying to geocode is complex and you don't really trust any individual geocoder's result. In that case, we can use a tool like Python, and specifically the pandas library, as well as a library called geocoder, to get geocoded results from a lot of different APIs, Yahoo and Google and Bing and all this, and then kind of compare those results and maybe take the centroid. And in a sense, we're using big numbers to kind of smooth out any wrinkles in our geocoding process. So I have a really small data frame called DAT, and you can see I've put some addresses in here. All of these addresses are around Gainesville. And I'm going to use each of these 10 different publicly available geocoders through this code, which is going to send out those addresses to them and give back the geocoded result. And then I'm going to write the results of each one of those geocoders to CSV files, comma separated values files on my computer. So you'll see it'll take a few seconds. It needs to geocode all 5 rows for all 10 geocoders. So that's 50 different processes. The nice thing about using this kind of method from a big data perspective is the fact that none of the calculations here are taking place on your computer. They're taking place remotely on these APIs servers. If you have hundreds of thousands, you'll likely have to get a contract with them, but for most of the stuff we do, that's pretty good. So I've now written 10 CSV files from 10 different geocoders, and we'll continue in R to show you how to analyze them. Now that we've got the API results for our addresses of interest from Python, we can use R to kind of clean up those results and get the best points for each location. I'll point my R session towards where I wrote those results to using Python, load in a few spatial libraries here, and then load in some publicly available shapefile data from Alachua County, and you can get this from Alachua County's website. There's a few helper functions here to get distance and stuff like that. And then I'm going to say down here, for every single file in that folder I pointed it to, read in that file. And so I now have these different files that look like this. For example, each one has an address, a latitude and longitude, but of course they're going to be slightly different because they come from different sources. I'm going to put all the results. I'm going to basically take the mean latitude and mean longitude to make centroids, and I'm going to put all those results in a data frame called master. And now if we look at master, it's got those addresses I was interested in, and it's also got the mean longitude, the mean latitude, the mean error, these kind of statistics that I can use to say how good or bad I think that geocode was, how confident am I in the location. And then we can take a few more steps and again look at our Alachua County over here and put our points on there, and we see where my locations are. So that's pretty cool.